Hello, I'm Papia. Today we're doing an error analysis. So you remember that if you have to approximate a definite integral using a trapezoidal rule, then there is an error. So in this problem, we have to figure out if our definite integral is from 1 to 3 1 over x dx, and if you're using trapezoidal rule to approximate that definite integral, then what should n be such that the error is less than or equal to 0.00001. Okay, also recall that the error for trapezoidal rule is given by this formula right here. E is the error, absolute value of it is less equal to b minus a cubed divided by 12n squared times the maximum of the second derivative of the function with an absolute value inside a and b. Okay, so we have to figure out what is this n so that the error is less than or equal to this value. So to start the problem, let's first figure out all the different variables that's already given to us. For example, a and b, we know that a is the lower limit, so a is 1. Okay, what is b? b is the upper limit, so it's 3. Okay, what is n? We don't know. We have to figure out n. Okay, let's see. What else? We also have to calculate the maximum of this function. This is the second derivative of the function f. So, what is f? Well, f is the function which you are integrating. So, f is 1 over x. Let's figure out what the second derivative is, and then we can figure out the maximum of it. All right, so the first derivative, recall 1 over x, you can rewrite it as x to the power negative 1. So you just use power rule, and therefore it's negative 1 over x squared. That's the first derivative. Second derivative will be, again, this is x to the power negative 2, and you use power rule again. So this will be 2 over x cubed. Okay, so this is the function. You have to find the maximum value inside the interval 1 to 3. So think about it. The function is 2 over x cubed, right? Okay, take the absolute value for x between 1 and 3. Well, x is positive, so this whole quantity is positive. So this is just 2 over x cubed. Now, what is the max of it? Now look, x is in the denominator, right? So the maximum will be obtained to by taking the lower limit. So the max of this function will be, when you plug in, x equals 1. So 2 over 1 cubed, which is 2. Now we have all the information. Let's put them all in. So the right-hand side of this inequation, b minus a, remember b is 3, minus a is 1, cube that, divided by 12 times, we don't know n, so keep it as it is, n squared, times maximum of the second derivative is right here, and it's 2. All right, simplify this, 3 minus 1, that's 2 cubed, times 2 divided by 12n squared. Okay, so let's see. You can cancel if you want, and you can cancel one more 2 from here. So you have 2 squared, that's 4 over 3n squared. All right. Now don't forget what we are doing, right? We have to find n such that the error, this is the expression that we want, 4 over 3n squared, is less or equal to this given value, 0.00001, and solve for n. Okay, so let's flip the equation so that n is in the numerator and we can solve for it. So we'll have 3n squared divided by 4. If you're flipping it, remember the inequality also gets flipped. So it'll be greater than or equal to 1 over 0.00001. Okay, so what is n squared? Take the 4 and the 3 on the other side. So you multiply by 4, divide by 3. And then take square root both sides. Then you will have n greater than or equal to square root of the entire quantity. Okay, let's use a graphing utility to figure out what the number is on the right hand side. So square root of 4 divided by 3 times 0.00001 and tells you that n should be greater than or equal to, this is almost equal to 365.1. All right, so remember n has to be greater than or equal to 365.1. So what is the first integer that will do that? Of course, 366. So n has to be at least 366 so that the error will be less than or equal to this given value when you are using trapezoidal rule to solve that definite integral. Thank you.